My friends from the class of 1978, it's hard to imagine that 40 years have passed since our graduation. Many of us were fortunate to attend our Ruby reunion and reconnect on campus and on the Andaman Islands earlier this year. In addition to having a great time frolicking in the warm waters of the Andamans, we did find time to discuss how to give back to the Institute. Many views were expressed, and a common theme emerged around research excellence. Some of you already know that IIT Madras has been ranked as the #1 engineering institution in India 4 years in a row, based on the ranking framework established by the Ministry of Human Resource Development in India. However, global perception still lags. In an effort to catch up, many members of our class expressed enthusiasm to set up an endowment to fund faculty externships that will enable IITM to improve its academic and research excellence on a global scale. This program enables a faculty member's first visit to the world's best research institutions. Evidence shows that research developed in joint collaboration with top global institutions have a 50% higher citation rate. We have chosen to name this externship the Prakash Fellowship in memory of our deceased classmate, K. Prakash, popularly known on campus as Prak. The Prakash Fellowship is an endowment from which the interest will be used to fund a select group of faculty members to spend a few months in one of the world's best institutions or research labs in their fields. Our stretch goal is to raise 5 crore Indian rupees or 700K US dollars to support 5 IITM faculty members each year. Almost everyone who attended the reunion pledged an amount. Some chose to make their donations over a period of a few years. I encourage all of you to contribute to the Prakash Fellowship. While any donation amount is welcome, a pledge for larger amounts spread over a few years will help us achieve our goals faster. If you've already made a contribution, I'd like to thank you for your generosity and support. We've already collected 1 crore rupees, and the interest earned is sufficient to fund 1 externship. The first recipient is Dr. Anubhav Roy from the Department of Applied Mechanics. He will be proceeding to France next summer. And to tell you more about how your support will help, here's Dr. Anubhav Roy.
Hi, I'm Anubhav Roy. I'm a faculty in the Department of Applied Mechanics. I belong to the fluid mechanics group there. I work in the area of waves, instabilities in flows, and also looking into effects of particles in flows. Now these two are of primary interest when we are trying to understand geophysical flows, because at that scale, instabilities, waves, and also the presence of small particles, how does this influence? In my group, I use different theoretical tools, merging them with computational techniques to better understand and model these problems in fluid mechanics.
Okay. Sir, is there any particular reason that you had to choose this particular field of research?
So the broad area of climate science has different sub-aspects to it. One particular aspect is the fluid mechanics aspect, which we approach from a purely mechanics perspective, where understanding the flow phenomena, there are different time scales, different length scales, where you can have, we all have seen climate events happening over the period of few hours to few days, and then when we go to a modeling aspect, all of us basically do modeling on a much larger time scale. This is always a concern, because if we are not able to understand what is happening on a smaller time scale of the order of few hours or days, we will not be able to use the bigger models which all of us run to give better weather prediction. So at the basis, we need a better understanding of the micro problem which is happening, which is beyond the scope of all predictive methods that are there right now.
Can you please tell me something about your team members and how are they, their collaborative?
So right now, as part of this research collaboration that I'd be undertaking, so this is with ENS Lyon in France, this is with the group of Professor Thierry Doxor. So the basic problem that we're interested in understanding is there's a lot of mixing that happens in ocean and atmosphere, and this mixing and the energy budget that is there in the ocean and atmosphere is driven by very, very fine scale instabilities that are happening. Now, there is not a proper understanding that exists regarding these fine scale instabilities that are there all around us. It is happening all around us, and it is always there to influence what we observe on a much larger time domain over a much larger lens scale. To understand this, one particular approach is to actually look at the waves that are there in the atmosphere and the ocean. These waves are basically moving around in an environment where density is varying. The density is not a constant. As we go to upper atmosphere, the density gets lesser, and similarly in the ocean, the density varies. The inhomogeneity in this density drives these waves in the system, and the interaction of these waves finally play a big role in this mixing process. So at my group, what we are trying to understand is how does these interactions of the waves actually occur, and then the bigger question is, whatever we model, how good are they? Do they actually match on to what you would actually make an observation in a real life scenario? So in that context, Professor Thierry Doxo at ENS Lyon, they have a very niche facility there, experimental facility, where they can do these kinds of, replicate these kind of geophysical flows in a lab scale. So they have a facility which can actually trigger waves in a lab scale facility. It's a very novel generator because you're trying to replicate something which is happening in a larger uncontrolled oceanic or atmospheric setting. So with this niche facility, they can actually test a lot of hypothesis and modeling that we do, that whatever we are proposing in terms of how these interactions are occurring, which finally leads to the mixing, that is the broader mixing that we are talking about, how much of that is actually the real stuff. And that can only be seen or verified via experiments. So this visit that I'll be undertaking next summer would be targeted towards doing this collaborative exercise where his group would be able to carry out experiments validating some of the modeling predictions we have. I would like to thank the class of 1978 for giving me this wonderful opportunity. Professor Prakash Swami, whatever I have read about him, he is the role model for any young researcher like me. And being able to, this opportunity really gives us that mobility, that extra mobility that takes our research from a good level to something that can make a sizable impact. And this is, I believe, one such fantastic opportunity that the alumni has created for young faculty, people who have just joined the institute. We have exciting ideas, we have a lot of things we want to try out, and when we get this extra additional push from the alumni, that actually gives us, that really helps us in many ways. So I would like to thank the entire class of 1978 for giving me this opportunity and thinking this problem to be interesting enough.